This video is an introduction to oxidation reduction reaction. By the end of this lesson, you should be able to define oxidation and reduction reaction, abbreviated as redox reaction, differentiate between oxidation and reduction, and identify real-life examples of oxidation and reduction reaction. Now, did you know how rusting occurs? This is a daily life encounter in your nails, at your window bars, and many others. If an iron object is left out in the rain, a reddish layer is deposited. After a few days, this layer is called rust. Iron reacts with oxygen of the air in the presence of moisture to form a substance called iron oxide, which is the rust. This is a chemical change and an oxidation reduction reaction. Iron loses electrons in the presence of water, and oxygen is reduced by gaining electrons in the presence of water. This could be chemically represented as iron plus oxygen plus water to give iron oxide, that is the rust itself. Now, what is an oxidation reduction reaction? An oxidation reduction reaction, that is the redox reaction, is a chemical reaction. It is a chemical reaction that involves the transfer of electrons. Consider the reaction in the diagram. Atom A reacts with atom B. A transfers its electron, thereby becoming positively charged, to atom B as the receiver, then becoming negatively charged. A is the giver and B is the receiver. What happens between them is transfer of electrons, where A become positively charged by giving its electrons and B become negatively charged after accepting an electron. If we could remember the rusting process, it occurs in the presence of water. So there are certain characteristics associated with oxidation reduction reaction. This type of reactions occur in aqueous solution, as the water present before the rust occur, and they are spontaneous, meaning they occur at the same time, both the oxidation and reduction. Now, what is oxidation? Since it is about two concepts, oxidation and reduction, what is specifically oxidation? Oxidation could be defined in two basic ways: one in terms of electron transfer, and two as a result of changes in oxidation number. In terms of oxidation number, oxidation is a chemical process that involves the transfer of electron, but in this aspect, oxidation results in the loss of electrons, as A loses its electrons to B. In terms of changes in oxidation number, oxidation results to increase in oxidation number. 0 ideally is less than a positive number, so it results to increase in oxidation number, which we will talk about later. You might guess me right. Always when a person gives, he is full of resources, so A there become positive, having higher oxidation number. A, that is atom A before, is 0 charged, but after giving its electrons to B, then it becomes a positive charge, being also the one that gives its electrons out. Now, what is reduction specifically? Reduction, we could hypothetically guess that it is the opposite of oxidation. These two could be defined in two basic ways: in terms of electron transfer and as a result of changes in oxidation number. In terms of electron transfer, then you can guess it. In terms of electron transfer, reduction is the gain of electrons. Atom B gains electrons from A. That means it is being reduced. It is the receiver. Reduction, again, in terms of changes in oxidation number, we might guess 2, since it is the opposite of oxidation. In terms of changes in oxidation number, reduction results to decrease in oxidation number. Reduction results to decrease in oxidation number since it is the receiver, hence a negative. So reduction results to decrease in oxidation number as an opposite to oxidation, which results to increase in oxidation number. Now to typical examples. Consider the reaction between zinc and copper 2+ to give zinc 2+ plus copper. Initially, zinc is full of its electrons, and copper 2+ on the other hand indicates that it has already lost its electrons. After they react, zinc gives its 2 electrons, becoming positively charged. Hence, zinc lost its electron and copper gains electrons. Hence, zinc is oxidized and copper is reduced. Typically, in the second example, in a reaction between hydrogen molecule and silver ions, same process as in the example above occurs. Hydrogen is full of its electrons and silver has already lost its electron. After they react, hydrogen gives its electron, becoming positively charged to silver. Hence, hydrogen lost its electrons and silver gains electron. Hence, hydrogen is oxidized and silver is reduced. Daily life examples of oxidation reduction reaction. There are several daily life examples of oxidation reduction reactions that occur close to us, but we are not conversant with them. Redox reactions occur during photosynthesis in green plants. That's the green pigmentation obtained by plants. It is a typical oxidation reduction reaction and a chemical process. It is also carried out in setups called the electrochemical cells. Yes, you have seen batteries, right? Typically, oxidation reduction occurs. So next time when you on your touchlights, know that oxidation reduction happens then. Now let's have a recap. Oxidation reduction reaction is a chemical reaction that involves the transfer of electrons. For oxidation and reduction, memorize the secret words. Oil rig, meaning oxidation is loss and reduction is gain of electrons. This will be helpful for you in the future when we explore oxidation reduction reactions. Oxidation reduction reaction is important to our daily lives. It occurs spontaneously and in aqueous solutions. Take note of that. Now your exercise, differentiate between oxidation and reduction in your exercise books.